Let us first understand what is Riemann integrability. The geometrical meaning of integration is related to the area. So, first, I am not going to the options. Let's suppose this is a function and this is the interval. This is x1 and this is x2. Interval here for the function fx. Riemann integrability also involves the area, and in this integrability we partition the whole area into a large number of small areas of equal length. We consider this area. Length of part is xi minus xi minus 1. This point is our xi minus 1 and this point is our xi. So the length is xi minus 1. The minimum value of the function, suppose it is mi. Minimum means here you see the height varies. Okay, so among these infinite heights you have to choose the least height. This is the one part. If you add all those parts in the same way, then you have a sum, and this sum may be a single value or maybe a range. If it is a single value, then okay. If a range, then in that case you have to find the supremum value, the highest value. Okay, so we say this sup L fp. In the same way, we consider the same part again, and its length is obviously xi minus xi minus 1. Okay, but this time height varies, but this time you have to take the greatest height. Suppose it is mi. Okay, so this represents the area, approximate area of this part, and in this way if you add all these parts, then you have a sum. So again, this sum may be a single valued or it may be a range. If it is range, then you have to take the least value. Okay, so this we say we have to take the least value of this range, and that is called inf u f p. If these two are equal, for any function, if these two are equal, then we say that the function is Riemann integrable. Okay, so let us now go for the options. Here integrand, this is our integrand, and it is a continuous function in t. Okay, now see the upper limit. Upper limit is x is also a continuous function. The lower limit, you see a constant, 0 is a constant, and you must know that constant is also a continuous function. So all these are continuous function. So this function in option A is continuous, and every continuous function is Riemann integrable. So option A is correct. And for the same reason, B is also correct, because B is also a continuous function. If you see option C, then it says that this is our interval for the function fx 0 to 1, and in that if you take the rational values, then the value of function is 1, and when you get other values other than rational values, then its value is minus 1. So this function is discontinuous at every point. when you go to find these two values -1, and when you go to get inf UFP, then you have 1. Both are not equal. C is not Riemann integrable. In option D, you see this function is discontinuous at only one point, and that point is x equals to 1. At x equals to 1, the function given in option D is not continuous. But except that point, this function x fx equals to x is continuous for all those points lying in this interval. When we draw the graph 0 to 1, then the area will be like this. For this option D, when we get the area using integration, actually we find the area like this. We take a line, thereafter another line, and in doing so we draw lines attached to the previous one, and in this way if we proceed, then we have the area. So here in our question, one line is missing. One may argue that okay, if one line is missing, then obviously its area will be less, because one may say that if you have 4 lines and you are missing one, then you have now 75% of lines. For example, I have taken 4, one is missing, then here we compare one line with 4 lines. Both are finite. But here in this case, if you go from this point to this point, suppose this is our graph and this is one. If you exclude one, then from this point to this point just before one, there are infinite number of lines. Okay, like this. Infinite, because for one point you can draw a line. So there are infinite number of points from this to this. So if you subtract 1 from infinite, then still you have infinite. And the same thing some people say in another terms, and they say that at one point the function is discontinuous and a point has zero measure. Zero measure means you see here the interval. Suppose this is our interval. Okay, so measure of this interval is 1 minus 0, greatest point minus the lowest point, that is 1. So measure is 1, and this point 1 can also be written in interval form. That point can be written in interval form, as like you see on the screen now I am writing. And obviously this has zero measure. Whenever a function like this has a finite number of discontinuous points, then that function is also Riemann integrable. So our this option D is also correct. So correct options are A, B and D. These 3 options are correct.